Hey everyone! So today we are looking at lesson 9, applying areas of circles. So let's go ahead and jump right in. So comparing areas made of circles. So each square has a side length of 12 units. Compare the areas of the shaded regions in the three figures. Which figure has the largest shaded region? Explain or show. So the shaded region is the blue portion of this. The circles are being cut out being cut out of the square. Now, each of these squares has side lengths of 12. So that means their area is 12 times 12, which is 144. So all of these squares represent 144 units squared for their area. Now, what we have to figure out is the area of the circles to subtract out of that 144, okay? So in this first one, notice the sides of the circle are on the sides of the square, which means the diameter of this circle, so the diameter is 12, so the radius is 6. So area equals pi times 6 squared. So 6 squared is 36. So this is 36 pi. Now, an approximation of what 36 pi is 113.097. So that's approximately what 36 pi represents. So now we want to take our 144 and subtract our 113 and 97 thousandths, and we're going to end up with 30.903. So we end up with 30 and 903 thousandths. So 30.903 units squared. So that's how much is shaded. So that's the blue area of this. So all these little curved triangles we have here, that is the 30.903. Once again, sorry about the fact that it keeps trying to do cursive. I don't know. Not sure what it's doing. All right, so for B, once again, our whole square is 144. But now we have 4 circles in here. 2 circles to go from the side of 1, so to go from here all the way across, that's supposed to be all the way up, is 12. So half of that, or 1 circle, would be 6. And so then our radius would be 3. So, once again, I don't know what it's doing. Sorry, it froze. Hang on. Maybe not. Okay. So area equals pi 3 squared. Now, 3 squared is 9. So 9 pi represents each one of these circles. So they are all 9 pi. So let me erase this real quick. And we have how many of them? Well, we have 4 of them. So this is 9 pi, 9 pi, 9 pi, and 9 pi. If we add all those together or take 9 pi times 4, what do we get? 36 pi. Now, is that not the same thing that we got over here for our 1 circle? Yeah. So once again, in this one, the amount left over, the shaded region, is 30.903 units squared. So it's the same for this. So let's take a look at C. Here, once again, 144 is the whole area of the square. We have 3 circles going across. So we know all the way across is 12, but now we need to divide that by 3. So 12 divided by 3 is going to give us 4. So 4, it's the diameter of 1 circle. So that means 2 is the radius. So area equals pi 2 squared, which equals 4 pi. Now, how many circles are there? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to take our 4 pi and multiply it by 9, and we end up with 36 pi. So the circles in each one of these all represent 36 pi, or 113.097 units squared of the area. So in every single one, they're all the same. So all the same area. So the shaded area is all the same. So it didn't matter that we made it one big circle, 4 little circles, 9 little circles. Because they were all equivalent, these circles were equivalent to one another. It didn't take up any more space than what this one large one did, which is kind of interesting to think about because it seems like, there's a pretty big section here in the middle and here on the sides and each one of the corners in the center. There seems like a lot of places. Same with over here. It seems like we have a lot more of the shaded region, but we actually don't because look, our corners shrunk down so much more. So it just dispersed all this space on the outside of the first big circle into the in-between spaces. And so it worked out that the amount of area that's left over is all the same. All right. Each square in figure D and E has a side length of 1. Compare the area of the two figures. Which figure has more area? How much more? Okay, so here are our figures. So it told us that the side length of the square is 1. So 1 times 1 is 1. So we know we've got 1 and 1 there. And 1. It's going to drive me crazy that it keeps doing this. 1, 1, 1, 1, 1. So already the first one has 2. The E has 4 units. So it says 4 squares, whereas this one has 2 squares. So 4 squares, 2 squares. Now, in figure E, we have 1, 2, 3, 4, 5, 6. Now, each of these 6 pieces represents a quarter of a circle. So we have 6 quarters of circles. Now over here, we've got half circles. So we've got a half here, half here, half here, and half here. So we have 4 half circles. So to find the area of the half circles and the quarter circles, well, for the half circles, we're going to do 1/2 pi r squared because it's half of a circle. Well, notice if all the side measures are 1 on this square, then the radius is 1 for this. So we're going to have 1/2 pi 1 squared. 1 squared is just 1, so we're going to have a half pi, and 1/2 pi is 1.571. And we have 4 of those, so we're going to multiply that by 4. And we end up with, this is 2 plus 6.283. So we have 2 plus 6.283, because that's the 6.283 is when we multiply the 1.571 by 4, because there's 4 of the semicircles. And so we end up with 8.283 units squared. I think, did it give us? Yeah, units squared. Now, over here, we have quarter circles. So can you guess what the equation is going to be? 1/4 pi r squared. Once again, I don't know what it's doing. Okay, 1/4 pi r squared. So we have 1/4 pi 1 squared. 1 squared is just 1, so 1/4 pi gives us 0.78. Oops, supposed to be an 8. Maybe. Hang on. There we go. Sorry, I do not know what my computer is doing. So 7, 8, 5, 4. So the area of each of these quarter circles is 0.7854. We have 6 of them, so multiply by 6. So times 6 will give us 4.71, let's see, 7.4124. So now this is going to be added to the 4 from the 4 squares up here. And so when we add 4 to that, we're going to get 8.7124. So if we compare these, which one's bigger? E is bigger, so E ends up being the bigger one. So even though we had semicircles or half circles over here in D, it ended up being more, because notice we have the 4 full squares here. So those 4 full squares helped us out when we had the quarter of the circles. So the difference between these, if we subtract 8.7124 by 8.283, we're going to get 0.4294 bigger. So E is, once again, sorry about the weird lines through everything. So there is what you're looking at. So sometimes just at a glance, it may seem like something might be smaller, but it ends up being bigger, or it ends up being the same. Like in our first example, it seemed like the last one probably should have had more area, but it didn't. It had the same as the other two. All right, so your keyword for this lesson is compare, compare. If you guys have any questions, feel free to ask. Have a great day, guys. Bye.